So this is 2.2b, and this is just a table of your reference angles. So notice if we have an angle theta, its reference angle is theta. It doesn't change when you're in that quadrant. Here, when we have an angle theta, its reference angle is going to be this one here. And this one, if we have an angle somewhere above 180 but less than 270, and it goes here, my reference angle is here. And remember, I was drawing lines to make triangles. That doesn't show up very well. Let's try black. And this one here, and this one here. And then if the line is between 270 and 360, if that angle is like there, the reference angle is right here. Okay, and again, that's all you have to focus on is that triangle. You don't worry about anything else, okay? Because the answer you get for that triangle for your trig functions is going to be equal to this one here. That's why it's called a reference angle, is you're using that angle as your reference to find stuff you need for everything else. So let's say we're doing example 2, and it says find the values of the trig functions, which means they want all 6 trig functions, for a 210 degree angle. So we go over here, 210 degrees, draw that line, so that's 210, and here is my reference triangle. And this angle right here, 210, and the difference between 210 and 180, which is what I get when I go over to this part of it, is 30. So I know this is 60. And this is 90, so it's a 30, 60, 90 angle. And so then I'm just going to find the sine of a 30 degree angle. Well, the sine of a 30 degree angle is 1/2, right? But look where we're at. All students take calculus. Tangent and cotangent are the only ones that are positive in that quadrant. So we just make that negative. So the sine of 30 is negative 1/2, which means the sine of 210 is negative 1/2. It's the same ratio. So that's all you're going to do. You're just going to take the sine, cosine, tangent, etc. of 30 and get the answer. And that's going to be the sine, cotangent, whatever, of 210 based on whether or not, you're in the third quadrant, whether or not it's tangent or cotangent. Tangent and cotangent are positive here. Everything else is negative. So one of the things you might have realized here, in the first quadrant, everything is positive. In the second quadrant, 2 of the 6 are positive, 2 of the 6 are positive, 2 of the 6 are positive. So I don't know if that helps or not or makes any difference, but that's just something that you notice. So let's look at example 3. Find the exact value of each expression. So again, we're not interested in fractions, we're not interested in decimals. We're interested in fractions, complete with radicals if necessary. So we're trying to find the cosine of negative 240. Now, if you remember, we always start from this line here. Normally we go in a counterclockwise position. If it gives you a negative on there, it means you're going to start here and go the other way. 90, 180, and then I'm going to get rid of that, 240. So we've got a line all the way around there to 240. So the question now is, what do I do with that? I draw a triangle, always, 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 to the x-axis, 90 degrees. So that's a 240 degree angle right there, but how far is it from here to here? Because that's what we're interested in. Well, it's 240. And we know this is 180, so 240 minus 180, that's going to be a 60 degree angle. So it asks me to find the cosine of negative 240, which is the same as finding the cosine of that 60 degree angle there. So my cosine of a 60 degree angle is adjacent over hypotenuse. And what are the lengths of my sides on a 30, 60, 90 angle? Okay. One of the things is my triangle doesn't really look that 30, 60, 90-ish. Actually, it should. I probably can't even get rid of it now. let's see here. Let's make it more, that's more of a 60 that way. Okay, so cosine of 60 is adjacent over hypotenuse. Well, that's 1, that's 2, that's square root of 3. So my cosine is going to be adjacent over hypotenuse, which is 1/2. And I'm in the second quadrant, all students, so sine is positive in there, so cosine has to be negative, so I get negative 1/2 for the cosine of 60, which is the same as the cosine of negative 240. So let's look at the tangent of 675 degrees. So tangent of 675, I'm going to take 360 away from it, because remember, anything above 360, you just start subtracting 360, and that gives me 315. So I'm interested in the tangent of a 315 degree angle, which is, that's 270, so it's going to be right around in here somewhere. So let's get rid of this. In fact, let's see, what angle is that? 360 minus 315 is going to give me a 45 degree angle. So this is 45. So I know this is 1, this is 1, this is square root of 2. And it's interested in finding out the tangent of 675. Well, the tangent of 675 is going to be the same as the tangent of 45, because it's the same line right here. We just went around a lot until we finally stopped there. But it's the same triangle. So if I find the tangent of 45, I've also found the tangent of 675. So again, all students take calculus. Cosine is positive there, so I know tangent is negative. So the tangent of 675 degrees is going to equal negative something. Negative what? Opposite over adjacent. 1 over 1. So the tangent of 675 is going to be negative 1.